Yes, class. Let's continue with another question, which said balance the following redox reaction in basic medium. To balance the redox reaction in basic medium, we follow the same steps like in acidic medium, but at the end we are going to add hydroxyl ions in all sides, in reactant side and in the product side, which are equal to the number of hydrogen protons present in the acidic equations. Now, here when we look here, our equation undergo both oxidation and reduction reaction. When you say redox reaction, you say that it is reaction that undergo both oxidation and reduction. When you find the oxidation state for lead here it is 2 positive. When you find here, you get 2 times 2, you get 4. So it undergo oxidation. Means in the reactant side it is 2 positive oxidation state, and the product side 4 oxidation state. So it undergoes oxidation. The same applies when you find the oxidation state for sulfur here. It was decreased from positive 6 to negative 1. Now this undergo reduction. So this equation is redox reaction, and we are going to balance it in basic medium. Half oxidation reaction. Half oxidation reaction. Our half oxidation reaction here is this one, lead. So it is lead 2 positive to form a lead oxygen 2. Now step 1 for half oxidation reaction is to balance materials, and the materials we are going to balance is atoms that present here, and we are going to balance atoms apart from oxygen and the hydrogen. Here we have lead. Lead is already balanced. Here we have 1 lead, and in the product side we have lead 1. So reactant side 1 lead, product side 1 lead. So no need to balance it. We are going to balance oxygen. So step 1, balancing oxygen. Step 1, balance oxygen atom. Balance oxygen atom. So to balance oxygen atom, take your equation as it is, like as it look here. You have to take it. It is lead 2 positive to form lead oxygen 2. Here in the product side, when you look on your equation here, you see here in the product side there is 2 oxygen. In the reactant side there is no oxygen. So to balance oxygen, always we add the number of water molecules is like that, or number of oxygen present there. So in the product side we have 2 oxygen, so we have to add 2 water molecules in the reactant side where there is no oxygen. So add 2 water molecules. So when you look here in our equation here, now in the reactant side we have 2 oxygen, and in the product side we have 2 oxygen. We have 1 lead, we have 1 lead. What is not balanced here is charges and the hydrogen, because in the reactant side we have 4 hydrogen, and in the product side there is no hydrogen. So step 2, balance. Step 2, balance hydrogen atom. So to balance hydrogen atom, we have to take our equation as it is. It is lead 2 ions plus 2 water molecule to form lead oxygen 2. Here we have how many hydrogen? 2 times 2, we get 4 hydrogen protons, and in the product side there is no hydrogen. So add 4 hydrogen proton in the product side. So in the reactant side 4 hydrogen, in the product side 4 hydrogen. We have 1 lead in the product, we have 1 lead in the reactant side. We have 2 oxygen in the reactant side, we have 2 oxygen in the product. So this equation is balanced in terms of material. What remains here is to balance charges, because charges are not balanced here, because here we have 2 charges. We have 2 charges in the reactant side, and we have 4 charges in the product side. Now step 3, balance charges. Take your equation as it is. Now before continuing with balancing the charges, mark these equations. so that you can simplify at the end. Mark this equation as equation 1 in the first step, mark this equation as equation 1, and mark this equation as equation 2. So step 3, we have to copy this equation 2 here. It will be lead 2 ions plus 2 water molecules to form lead oxygen 2 plus 4 hydrogen protons. Now, here as you see here, charges. Here we have 2 charges in the reactant side, and in the product side we have 4 charges. So to neutralize, we have to neutralize 2 charges here, so that we can remain with 2 positive charges. And here we have 2 charges, so that the equation will be balanced. So balance 2 by adding 2 electrons in the product sides. When you add 2 electrons, means you neutralizing 2 charges here, and you will remain with 2 charges in the product side, and you have 2 charges in the reactant side. So this equation is balanced in terms of materials and the charges. So mark this equation as equation 3. Mark this equation as equation 3. After marking this equation as equation 3, when you look into, you see here, this equation already balanced. Oxidation reaction. Half oxidation reaction already balanced. Means you have 2 lead, you have 1 lead, you have 1 lead, you have 2 oxygen, you have 2 oxygen, you have 2 charges, you have 2 charges in the product sides, and you have 4 hydrogen, you have 4 hydrogen product sides. So this equation is balanced in terms of material and charges. Now we are going to balance a half reduction reaction. Half reduction reaction. Half reduction reaction here. Our half reduction reaction here is this here. Sulfate to sulfide. So sulfate here we have sulfate formed to form sulfide negative. Here, as you see here, first step always we are going to balance atom apart from oxygen and hydrogen. And here atoms that are not oxygen and hydrogen, here we have only sulfur. Here we have 1 sulfur, and here we have 1 sulfur. It means it is already balanced. Now what remained is oxygen, because when you look here, you have 4 oxygen in the reactant side, and there is no oxygen in the product side. Means this equation is not balanced in terms of oxygen atom. So step 1 is to balance oxygen atom. Balance oxygen atom. To balance oxygen atom, very simple. Take your equation as it is. It is sulfate oxygen 2 negative to form sulfur negative. Understood? And here we have 4 oxygen. Means in the reactant side, in the product side, we have to balance this oxygen. To balance oxygen atom, always we add water molecules the same number of oxygen. The number of water molecules equal to the number of oxygen, means we are going to add 4 water molecules. So plus 4 water molecules. So when you add 4 more water molecules, means you already balance the oxygen, because here you have 4 oxygen in the reactant side, and here you have 4 oxygen in the product side. Understood? So if there is 4 oxygen, means this equation in terms of oxygen already balanced. So mark this equation as equation 4. When you look here, there is something that was appeared here, is hydrogen atom, because at the first, before we didn't have in the hydrogen in the first equation. So when you look here in this equation, you see we have 4 times 2, we have 8 hydrogen protons in the product side. We have hydrogen atom, 8 hydrogen atom in the product side, but in the reactant side there is no hydrogen atom. So step 2, we are going to balance hydrogen atom. So step 2, balance hydrogen atom. Step 2, to balance hydrogen atom. Very simple. Take your equation as it is. It is sulfate oxygen 2 negative to form sulfide negative plus 4 water molecules. Understood? This equation, when you look here, Hydrogen is 8. In the product side there is no hydrogen, so we have to balance hydrogen. So it will be 4 times 2, you get 8. So we have to add 8 hydrogen protons in the reactant side so that we balance hydrogen atoms. So it will be 8 hydrogen protons. Here when you look our equation in terms of material that we balance, because we have 1 sulfur in the reactant side and we have sulfur 1 sulfur in the product side. We have 4 oxygen in the reactant side. Also we have 4 oxygen in the product side. And we have 8 hydrogen protons in the reactant side, and we have 4 times 2 get 8 hydrogen atoms in the product. So this equation is balanced in terms of materials. What remains is charges. So step 3. Balance charges. But before balancing charges, mark this our equation so that we can go in our series. Means this equation will be equation 5. Understood? Now we are going to balance charges. We take this equation 5 here. We have sulfate, oxygen 2 negative, understood? Plus 8 hydrogen protons. Understood? To get sulfide plus 4 water molecule. Here, what remains was charges. When you look here, we have 80 charges, means 8 positive charges. So 8 charges, we have 2 electrons here. So you have to minus 2 here. When you minus, you get 6 charges. So you remain with 6 charges. But in the reactant side here, we have 1 electrons. Means there is exceed. Here there is deficiency of 6 charges, and in the product side there is excess of 1 electron. Here there is deficiency of 6 electrons, but in the product side there is 1 electron. Means we have to add 7 electrons. When you add 7 electrons, means you neutralize 6 charges remain here, which was deficient, and you will remain with 1 electron, which is equal to the 1 electron in the product side. So this equation was balanced in terms of charges. So mark our equation in equation 6. Mark this equation as equation 6. That's it. Now when you look at our equation here, this was half reduction. So when you look at in terms of material, sulfur 1 in the reactant side, we have 1 sulfur in the product. We have oxygen 4 oxygen, 8 hydrogen, charges balance. So this equation was balanced. In terms of material, charges. Now we are going to combine this equation. Means we are going to combine half oxidation reaction and half reduction reaction. Here we have half oxidation reaction here. We have our half oxidation reaction, which is equation 3. So you have to combine to get overall. Combine equation 3 and equation for half reduction reaction, which is this one, equation 6. Combine equation 3 and equation 6. So we have to take our equation 3, which is this one. Our equation 3 here is lead plus 2 water molecule to get lead oxygen 2 plus 4 hydrogen protons plus 2 electrons. And the equation, this is equation 3. And we have the half of oxidation reaction, half reduction reaction, which is this one. Our half reduction reaction, which is fully this one, which is balanced in terms of material and charges. We have to take that one which was balanced in terms of materials and charges, and which is not balanced, you are not allowed to combine with this one. Understood? Now we bring this one. So it will be sulfate 2 negative plus 80 hydrogen protons plus 7 electrons to get sulfide plus 4 water molecule. Yes, class, when you look here, our equation here, you will see. In order to balance this equation so that they will look similar, we have to multiply by 2 electrons in the first equation to multiply these 2 electrons in first equation in the equation 2, and the 7 electrons, so that will look similar. We have to multiply 7 electrons in equation 1. That's two. So it will be you take these two, will be like this, and 7 up in the first equation. So 7 times this, you get 7 lead ions, plus 7 times 2, you get 14 water molecule. Product side, 7 times redox dioxide, it will be 7 lead dioxide, 7 lead dioxide, plus 7 times 4, 7 times 4, it will be 28 hydrogen protons, plus 7 times 2, you get 14 electrons. So in the first equation we already multiplied by this 7. Now we go to this second equation. We have to multiply by 2 so that the electron will look similar. That's good. We will see so that the electron will cancel each other. So 2 times sulfate, get 2 sulfate, plus, but there is 2 negative here, understood? Plus 2 times 8, you get 16 hydrogen protons, plus 2 times 7, you get 14 electrons. In the product side, 2 times sulfur, you get 2s negative, plus 2 times 4, you get 8 water molecule. Now it's time for calculus. We have to add these two equations. Add to this equation. We have to add these two equations. How to add these two equations? Look here. We have 14 electrons in the reactant side, and we have 14 electrons in the product side. So we have to cancel this with this one. That's good. Also, we have 16 hydrogen protons in this equation. Also, we have 28 hydrogen protons. So 28 minus 16, you get how many? 28 minus 16, you get 12. 28 minus 16. 28 minus 16 is 12 hydrogen protons. And here we have in water we have 14 water molecules here, and in the product side we have 8 water molecules. So we have to minus the 8 water molecules here in 14. So 14 minus 8, we get 6. 14 minus 8 is 6 water molecule. So here, in terms of water, we already 14 minus 8 to get 6 water molecule. Here what remains now? Already. Now it's just to combine all these two equations. Understood? So we get here it will be 7 lead 2 ions. Take it will be 7 lead 2 ions plus 6 water molecule plus, that's it. You have to plus first. You have to plus this in the product side first. You will be plus 2 sulfate, 2 negative, plus, yes, plus, no, nothing. So in the product side will look like this. Will be 7 lead oxygen 2 plus, here, when you look here we get 12 hydrogen protons. That's good. You have to add plus 12 hydrogen protons, plus 12 hydrogen protons, plus, what remains in the second equation in the product is this one, 2 sulfate, plus 2 sulfate. So plus 2 sulfate. This is overall balanced equation overall balanced equation in acidic media. This equation is balanced in acidic media. What determines that this equation is balanced in acidic media is this hydrogen protons here. This determines the acidity of this equation or acidity of these solutions. That's good. Now, if this equation is in acidic, we need it to balance in basic medium. To balance it in basic medium, we are continuing. So we are going to balance in basic medium because this is in acidic medium. So to balance in acidic medium, before balancing in acidic medium, as you know here, we continue with the equations, but here no need. Understood? So take our equation as it is. Take your equation as it is. It is 7 lead 2 ions plus 6 water molecule plus 2 sulfate, 2 negative, to get 7 lead oxygen 2 plus 12 hydrogen protons. So that it will be easy, take these protons at the last, understood? So take this first. It will be plus 2 sulfide negative plus 12 hydrogen protons. Now, in order for this equation to appear in basic medium, we have to add the number of hydroxyl groups like that of hydrogen protons in both sides, in reactant side and in the product side. So in the product side, it is 12 hydrogen protons. We have to add 12 hydroxyl group in the product side and 12 hydroxyl group in the reactant side. So add here 12 hydroxyl group. Here in the reactant side also add 12 hydroxyl group. So here, after addition, it will look like this. 7 lead ions plus 6 water molecule plus, that's good, plus 2 sulfate, 2 ions, plus 12 hydroxyl group to get 7 lead 2 plus 2 sulfide plus, as you see here, we have 12 hydrogen protons and 12 hydroxyl group. You have to add all these because hydrogen plus hydroxyl get water. That's good. So it will be 12. This plus this, you get water. So it will be 12 water molecule. So when you look at our equation here, what appears here is this proton here, hydroxyl, and this determines the basicity of our equation. So this equation was balanced in basic media. So this is overall balanced equation, balanced redox reaction in basic media, and something that determines that this equation is in basic is this hydroxyl group. Thank you very much. See you later.